Hey, it's Mr. Vise with your classwork video for lesson 4, unit 5. Today we'll be talking about standard 8 FA2, which is compare properties of two functions, each represented in a different way. We're talking about interpreting the equation y equals mx plus b as defining a linear function whose graph is a straight line. Give examples of linear functions that are not linear. And overall, we're going to be tackling F8 FA2 mostly, comparing reputations in different ways. And we're going to be doing that by and looking at graphs, tables, and equations. And our objective today is I can compare inputs and outputs of functions that are represented in different ways. And so for our warm-up, we have a linear system of linear equations. And so we're going to they're both in the form of y equals mx plus b. And so what that means is that you set them y equals y, right? When they're both in this form, is you set y equals y here. So 7x plus 10 is equal to negative 4x plus 23, right? And then you're going to add 4x to both sides. You're going to have 11x plus 10 equals 23. Right? You're going to subtract 10 because you want to isolate the variable. So you're going to get 11x equals 13. And then you're going to divide by 11. So you're going to get x equals 13 over 11. So let's write that down. So y equals y. And then you're going to have replace the first y with 7x plus 10. The second y with negative 4x plus 23. And then you're going to add the 4x to both sides. 11x plus 10 is equal to 23. Then you're going to have 7x equals negative positive 13. And you're going to divide by 11 on both sides. So you're going to get 13 divided by 11, right? And then I'm going to sneak in the equal sign right there each time. Okay. And then from there, you're going to complete the table based on linear equation. So what that means is you're going to compare. I've given you the inputs, and you have to find the input based on the linear equation. So I've given you the x, which is negative 5, 10, 3, and 4, and you have to figure out the y. The linear equation is y equals negative 3x. So here, you're going to replace, wherever you see the x, you're going to put negative 5. So negative 3 times negative 5. So that's negative 3 times negative 5 would be 15. 10 times negative 3, that's going to be negative 3 times 10 is negative 30. And then you're going to put negative 3 times 3, which is going to be negative 9. Then you're going to do negative 3 times 4, which is going to be negative 12, right? So it's going to be 15, negative 30, negative 9, and negative 12. Okay. And now I changed the inputs and the equation, so you're going to have different outputs, right? So now the equation is y equals 2x plus 3. So you're going to do that for negative 3, 7, negative 5, and 6. So y equals, you don't need to write that. You can just do 2 times negative 3 plus 3. So 2 times negative 3 is negative 6, plus 3 is negative 3. And then 2 times 7 plus 3. 2 times 7 is 14, plus 3 is 17. Negative 5 times 2 is negative 10, plus 3 is negative 7. And then 2 times 6 plus 3 is 12, plus 3 is 15. Okay. So you're going to have negative 3, negative 7, 17, negative 7, and 15. So from there, we're going to move on to 3.1, which is find the similarities and differences I have some here already that I found out. Can you find out some more? I found out that they all have x and y's. Do you see that? They all have numbers, right? They all are linear equations in different ways, right? So this is a linear equation. This is a linear equation. This is a linear equation also in a table, in a graph, in an equation. And so, is there something else that you can put there? Also, there are differences. Um, the way they're presented to you, one is visual, one is graphical, and one is numerical. So definitely check that out. Add something more there if you like mines. If you don't, put something different, right? And then the next section is going to be 3.5, 15 seconds at a time. So for this one, you're going to do the decimals activity if you weren't here in class. So decimals activity, it has a video in which you draw, which it converts the video into a graph. You can see that this graph is time versus the height of the waist of the ground. So you can see it was, wait for it to start over again. Okay, so you can see that he starts here and then he goes up the ladder and then he's the same height for a while. Then he sits down and then he stops for a couple of minutes and then he goes down, pops back up, and is done, right? So what do you notice about and what do you wonder about these two things? And then after you do that, I want you to click on this link right here and it'll bring up the decimals activity. And you click join, click sign in with Google, sign in with your Google account, continue the activity. And the way this activity works is you're gonna get a video. So that you can see here, I have a video. Let's go next one. So I have a video. I click play, and you can see this is the time right here. So I'm going to sketch the relationship between time and the height waist above the ground. So I'm going to do that right now. And so he's going up. So let's see, he's probably about 2 feet. So, and then he goes up until he climbs up until, let's see, until there. So he climbs up until about there, I would say there. And then he's steady until there. And then he drops down there. He drops down. He drops down till there. And then he waits to move. And then right there, he waits to move. And then he goes down. And then he pops back up. So that's my graph of that. And then I go to the next slide. It's going to give you the answer. It's going to put the answer on top of yours. So you can see there's mine. Pretty decent, right? Drops down, waits, goes down, pops back up, right? And so you're going to be doing that on your own. You're going to have an example where it's the amount of water going in the bowl, the amount of eggs in there, and then you're going to have his distance from the camera, the distance from the center of the carousel, and then you're gonna watch the answers. Like, so you can skip ahead and watch the answers. See, there's the answer there. So you're gonna be doing that on your own. Check that out. Do it on your own, please, and then it'll give you the answers at the end. Okay. So now for the next one, our objective is to I can compare inputs and outputs of functions to represent in different ways. So here's for 3.3, the temperature between noon and midnight in city A. So this is a graph. And then here, the temperature between noon and 6 for city B. So this is a table. So this is data in two different ways, a table and a graph. So now, which city was warmer at 4 p.m.? City A or city B? So if you look at city A, we can find the top here. So this is 59 degrees. And then we look for the top number here, 82. So the top number is 82. So city B was warmer. Which city had a bigger change in temperature between 1 and 5 p.m.? City A or B? So let's see. Here's 1 is like 50 degrees. 5 would be 57, so that's about a 7-degree change. And then here we got to look for 1 is 82, and 5 is 58, so that's going to be like 24. So city B had the larger drop. Now, what is the difference between temperature between city A and city B at 6 p.m.? So let's see. 6 p.m. 59, 6 p.m. 59. So zero would be the change. And now those are all we just found data from the table and the graph and compared in a different way. We just did the objective. Okay, so now here these are opinion questions. Which representation do you think is better for identifying the highest recorded temperature in the city, graph or table? So that's your opinion. So which one do you think will be easier to find the higher temperature, the graph or the table? So you put graph or table and why. Over here, you're going to put which is quicker for figuring out the change in temperature between 1 and 5 p.m., the graph or table, and why. So those are your opinions. So there's no wrong answer for those, just your opinions. And now from here, at the end, read the summary and then answer these two questions. These are also opinion questions. I'll be reading them, checking them out. And that's it for that. So it's a very kind of short video, but you're going to be doing a lot of work on Desmos today. So make sure you're doing that. And then you also still have your homework to check out. You can check out that homework video too. So I'll see you guys later. Cue outro music. Woo! Outro music.